Hello children, I am Rizwan. An important aspect in everyone's day-to-day life is to measure. Measuring the length of a rope, the distance between two places, finding the perimeter and area of plots and lands, building the structures under specified measures, etc. Are a few of the many situations where the concept of measure is used. It is said that the biggest invention by man is the wheel. The wheel is otherwise called the cradle of invention. What is the shape of a wheel? Circle, isn't it? In the things we use, apart from circles, we can also see different shapes like triangles, squares, rectangles, etc. Measurements play a vital role in everyone's life. Not only the persons who learn proper mathematics in schools, but also the layman uses logical thinking to apply the concept of measurements when he needs. For example, a carpenter who carves out the wooden wheels of a temple car wants to protect the outer surface with an iron strap. With all his experience, he says that a 22 feet strap will be required for a 7 feet high wooden wheel. We have already learnt how to find the perimeter and the areas of shapes like circles, triangles, squares, rectangles, trapeziums, parallelograms, etc. In this chapter, we shall see the parts of a circle and how to find the perimeter and the area of a sector. Learning outcomes. At the end of this lesson, you will be able to understand the basic definitions of a circle, including its center, radius, chord, and diameter. Differentiate between circular arcs, circular sectors, and segments of a circle. Calculate the length of an arc and the area of a sector using the central angle and radius. Solve problems involving circular geometry by applying formulas for the perimeter of a sector and the area of a circle. Keywords from this lesson are circle, radius, chord, circular arc, circular sector, central angle, length of an arc, area of sector. A circle is a path traced by a moving point so that its distance from a fixed point is always constant. The fixed point of the circle is called its center and the constant distance is called its radius. Further, if any two points on a circle are joined by a line segment, then the line segment is called a chord. A chord divides a circle into two parts. A chord that passes through the center of the circle is called a diameter. A diameter of a circle divides it into two equal parts. It is also the longest chord of a circle. Circular arc and circular sector. Look at the glass bangle and the pizza given in the figure carefully. Though both are circular shapes, what we understand is that the bangle indicates the boundary of the circle, whereas the pizza indicates the plane enclosed within the boundary of the circle. Thus, it is clear that the bangle indicates the circumference of the circle, whereas the pizza indicates the area of the circle. From them, cut a part as shown in the figure. Each of the glass bangle pieces represents circular arcs. Here, arc AB is a smaller one and the arc BA is a larger one. Each of the parts of the pizza represent the circular sectors. Here, A1 is a minor sector and A2 is a major sector. A part of the circumference of a circle is called a circular arc. The plane surface that is enclosed between two radii and the circular arc of a circle is called a sector. Each part of a circle that is divided by a chord is called a segment. Note: the part which has a smaller arc is called the minor segment and the part which has a larger arc is called the major segment. Central angle. The angle formed by a sector of a circle at its center is called the central angle. The vertex of the central angle of the sector is called the center of the circle. The two arms of it are the radii. In the figure, the shaded sector has the central angle AOB is equal to theta, and its two arms OA and OB are the radii of the circle. The central angle of a circle is 360 degrees. If a circle is divided into n equal sectors, the central angle of each of the sector is theta, which is equal to 360 by n. For example, the central angle of a semicircle is 360 degrees by 2, which is equal to 180 degrees. And the central angle of a quadrant of a circle is 360 degrees by 4, which is equal to 90 degrees. Length of the arc and area of the sector. We have already learnt that a circle of radius r units has a central angle 360 degrees. Circumference of the circle is equal to 2 pi r units. Area of the circle is equal to pi r square units. Length of the arc and area of the sector. First, let us take a circle. If a circle is divided into two equal sectors, we will get two semicircles. Length of the semicircular arc is equal to 1 by 2 into 2 pi r, which is equal to 180 by 360 into 2 pi r units. Area of the semicircle is equal to 1 by 2 into pi r square, which is equal to 180 by 360 into pi r square units. Similarly, if a circle is divided into 3 equal sectors, the length of the arc of this sector is equal to 1 by 3 into 2 pi r, which is equal to 120 by 360 into 2 pi r units. Area of the sector is equal to 1 by 3 into pi r square, which is equal to 120 by 360 into pi r square units. In the same way, if a circle is divided into 4 equal sectors, length of the arc of the circular quadrant is equal to 1 by 4 into 2 pi r, which is equal to 90 by 360 into 2 pi r units. Area of the quadrant is equal to 1 by 4 into pi r square, which is equal to 90 by 360 into pi r square units. What do we know from this? Length of the arc L is equal to theta by 360 into 2 pi r units. Area of the sector A is equal to theta by 360 into pi r square units. Perimeter of a sector. We already know that the total length of the boundary of a closed part is its perimeter, isn't it? What is the boundary of a sector? Two radii OA and OB and an arc AB. So, the perimeter of a sector is equal to length of the arc plus length of two radii. P is equal to L plus 2r units. So, perimeter of a sector P is equal to L plus 2r units. Let us see one example. Find the area of the hula loop whose diameter is 28 cm. Solution. Given the diameter D is equal to 28 cm. Radius R is equal to 28 by 2, which is equal to 14 cm. Area of a circle is equal to pi r square units. By substituting the values, we get 22 by 7 into 14 into 14. By simplifying, we get the area of the circle is equal to 616 cm square. So, the area of the circle is equal to 616 cm square. Let us see another example. A spinner of radius 7.5 cm is divided into 6 equal sectors. Find the area of each of the sector. Solution. Radius R is equal to 7.5 cm and N is equal to 6. Area of each of the sector A is equal to 1 by n into pi r square units, which is equal to 1 by 6 into pi into 7.5 into 7.5. By solving, we get 9.375 pi square centimeter. Let us see one more example. 4 identical medals, each of diameter 7 cm, are placed as shown in figure. Find the area of the shaded region between the medals. Solution. Diameter D is equal to 7 cm. Therefore, R is equal to 7 by 2 cm. Area of the shaded region is equal to area of the square minus 4 into area of the circular quadrant. That is equal to a square minus 4 into 1 by 4 pi r square. Now substitute all the values. We get 7 into 7 minus 4 into 1 by 4 into 22 by 7 into 7 by 2 into 7 by 2. By solving, we get 49 minus 38.5, which is equal to 10.5 square centimeter. Points to remember. A circle is defined by its center and radius with a constant distance from any point on the circle. Circular arcs are parts of the circumference, while sectors are the areas enclosed by two radii and an arc. The length of an arc and the area of a sector depend on the central angle and the radius of the circle. The area of a circle can be calculated using the formula pi r square, where r is the radius. Thanks for watching.